In 5.7, we're given some information about bond issued by Renfro. Renfro's bond is paying interest, or is paying its coupon semi-annually. And the coupon rate is 10%, and the par value is 1,000. So we can figure out that the coupon payment in this bond is annually $100, but because it's paid semi-annually, we're receiving $50 every 6 months. We know that this bond matures in 8 years, and the yield to maturity in the marketplace is 8.5%. So that is, the bond in the marketplace right now, the market bond, pays 8.5%. That also means that it pays $85 annually relative to the $100 that this bond pays. So since our bond has a greater cash flow than that you'd find in the marketplace, we can already deduce that our bond must sell above par value. Now, we need a little bit more information here if we're going to enter some values. We need to get our payment, and so our payment is equal to our par amount times our coupon rate. Let's do coupon payment. And let's also add in here an area for subperiods. So again, our coupon payment is equal to the par value times the coupon rate, and then we're going to divide by n so that we get the semi-annual coupon payment. Next, to find the present value, we're going to use the function PV. We could also set up the cash flows and use the NPV function, but the PV is much more direct and simplified. So we know that the yield to maturity is 8.5%, but recall that we're talking about a bond that pays semi-annually, so we're going to divide that by 2. Number of periods is T times N. The payment we've already adjusted for the semi-annual nature. And the future value is the amount that we'll receive upon maturity, which is the par value of the bond. There's no information indicating that this is a bond that pays at the beginning of the period versus the end, so we'll enter the default value of 0. So we see that this bond would cost an investor $1,085.80 today. The reason why it costs more is our bond every 6 months is paying $50. So if we set up 16 cash flows, versus the market that pays so the market bond pays $82.50, our bond pays $50. The $1,000 that you receive at the end of both these bonds is no different. So really then we're looking at the difference between these two bonds for identifying the value. That is the amount that you would pay above par. So we can see that every 6 months we receive $750. Now what we can do is use the NPV function. So we know again the rate, and we have to account for subperiods. And notice here that our amount comes out to $85.80. If we add the par value to this, we now get the exact same value for our bond. So what I'm trying to point here at the last part of this solution is, yes, earlier we found what the bond should sell for. However, that extra $85 is due to the $750 that we receive every 6 months for the next 8 years. That $750 that is the annuity of $7.50 semi-annually for the next 8 years, works out to a present value of $85.80. So that's why our bond sells over par value of $1,000 by $85.80.